All right, this is the Projectile Simulation 3. In this lab activity, you're going to explore horizontally launched projectiles. So it says, click on the link posted below in a Google Classroom. Set the simulation up like the photo to the right. So the speed will be 10 meters per second. The angle will be 0 degrees. The height will be 80 meters. This will simulate a projectile being launched horizontally. So click on Trace Path, Show Velocity Vectors, and Show Acceleration Vectors. So what it's saying is that I can change the speed that it's going to be launched at, I can change the angle that it's going to be launched at, and I can change the height from which it's going to be launched. So it says we're going to start it out at 10 meters per second. We're going to make the angle 0. So this is going to make sure it launches at perfectly horizontal. Now I'm going to make the height 80 meters. So this is going to be a height that it's going to be dropped from. There we go, all the way up to 80. There we go. Oh, wrong. It's sort of hard getting that right. All right. Well, I can. There we go. All right. So then I can hit trace path. I want to show velocity vectors and I want to show acceleration vectors. So once you do that, it says start the initial velocity at 10 meters per second, run the simulation, record the time to land. So it's going to be the time to land. That's going to be up here at the top. Then record the x displacement in the table below. So it's going to be, this is the y displacement. Well, it's falling down 80 meters. This is going to be the x displacement. This is how far is this projectile going to travel. So then you're going to increase the initial velocity by 10 meters per second and repeat. Place the results in the Google Sheets attached to the assignment and copy the chart. So this will give you a graph, but all we have to do is just run the simulation and it will say your x displacement there, and there's the time. All right, so I reset, then it says increase the initial velocity by 10, so it's going to be at 20 meters per second. I'm just going to run it again. There we go. Well, there's your x displacement right there, 80.82 meters, and there is the time, 4.041 seconds. All right, I'm going to reset it, go up to 30 meters per second. There we go. Oops, I need to do that. 30 meters per second. All right, and I'm going to start. All right, so there's my x displacement, 121.22 meters, and there's the time, 4.041. Reset it, go up to 40. There we go. Start the simulation again. Let's see here. There's the time, 4.041 seconds, and the displacement, 161.63 meters. Reset it all the way up to, let's see, 50 meters per second. There we go. Reset it and start. All right, so now I have, let's see, 4.041 seconds and 202.04 meters. All right, then I'm going to go all the way up to 60. There we go. Oops. All the way up to 60, and I'll launch it. There we go. So 4.041 seconds and 242.44 meters. All right, so you can probably tell, you can probably notice a pattern, especially with the time, but the graph will be able to show you that relationship. But a couple things to note, just look at the horizontal velocity, this red arrow, and notice the red arrow for the y velocity, and also this blue line, that's the acceleration. Notice, well, does the blue line ever change, right? So if I do that, or if I go really far down, look at the blue line. Does the blue line change, right? Or does that blue arrow change? All right, so you'll be able to answer the rest of the questions based on the graphs and the data from the simulation. So once again, this is the Projectile Simulation 3, the one on horizontally launched projectiles.